Hey folks, let's take a look at 13. So 13's intense. We're gonna break this down. And before I even get to the options in A through D, I wanna look at all of the traits I can spot off of the graph and how that informs me in terms of what my formula for my function is. So the first thing I notice is that there's a VA here at x equaling -1, right? So there's a vertical asymptote at x equaling -1. So that tells me, from there, I know I'm gonna have a factor of x plus 1 in my denominator only. Okay, same thing's about to happen here at x equaling 3, right? So I see that I have another VA at x equaling 3. So that's going to tell me I have a factor of x minus 3 in my denominator only. And I might be running out of room. Yeah, let me scooch this over to the left. I keep making that mistake on these videos. All right, in denominator, I'll put denominator only, just so I don't totally run out of room. Okay. I also see I've got a horizontal asymptote at y equals 3 here. All right, and with that, that tells me that the ratio of my lead coefficients between numerator and denominator is 3. So let me go ahead and write that my ratio of lead coefficients, let me not run out of room, lead coefficients is 3. All right, so these are all things to keep in mind. All right. I also see I have an x-intercept here at 4, 0, right? Right, and then I have another x-intercept at the origin at 0, 0. So what that's ultimately going to tell me, right? I have an x-intercept at 4, 0. So that tells me I'm going to have an x minus 4 in my numerator only, right? So factor of x minus 4 in numerator only. And then similarly, because I have one at the origin, right? And I'll put this over on this side just because I'm running out of room. Since I have an x-intercept at 0, 0, that tells me I'm going to have a factor of x, right? X minus 0, right? I'll write factor of, I could write it this way, x minus 0, but we don't usually write x minus 0. We'll just write x. And again, that's going to be in the numerator only. So what I'm going to do in a moment, I'm going to scooch this down and I'm going to start factoring all 4 of those rational functions. And then I'm going to see which one of those 4 match up with the traits that I've been talking about here. So let me go ahead and scooch this up, all right, till I can get all of those equations in view. All right, so just about here-ish. All right, so let's see what we've got. When I factor this, I can take out the GCF of x in the numerator. I've got x minus 4, and this is going to be x minus 3, x plus 1. Great. Here I've got a GCF on the numerator of 3x. That'll leave me with an x minus 4. When I factor out my denominator, again, I've got x minus 3, x plus 1. Great. Here, there's nothing to factor. Fantastic. Same with D, right? So C and D, fantastic. All right, so let's start naming some traits just so we can see how this works. So I'm going to start with x-intercepts. Let's start with x-intercepts. This is where your numerator only is 0. So if I look at this, where my numerator only is 0, I have something at 0, 0 here and 4, 0. Great, that's consistent. I'm not going to rule that out. I'll put a little check mark by that. Here I have x-intercepts at 0, 0 and 4, 0 because that's where my numerator is 0 and I don't have a common factor in the denominator with those. That's good. For C, if I look at my x-intercepts, I only have one at 4, 0. And that is not consistent with my graph. My graph had 2 x-intercepts, one at 0, 0 and another at 4, 0. So this is not going to be my answer. All right, and now if I look at D, if I wanted my x-intercept, my numerator zeroes out at 4/3, comma 0. Right? That is not correct. It's not that it's not correct, it just doesn't match my graph. Okay. And so that's going to limit us now to either A or B. And just for the sake of kind of writing some traits out, I want to show you if I was going to continue with C, it has a vertical asymptote at x equals -1 because the denominator is 0 there. If I look at its end behavior, I've got degree 1 in the numerator, degree 1 in the denominator. Since those are the same, I take the ratio of the lead coefficient. So for here, I would say my end behavior was that I had a horizontal asymptote at y equals 1, because this has an unsaid coefficient of 1, this has an unsaid coefficient of 1, 1 over 1 is 1. And just as a heads up, right, there's no factor common to the numerator or denominator, so I've got no holes. That actually is consistent with our graph, but the rest of these aren't, right? I did have a vertical asymptote at x equaling -1 on the graph, but it's missing the vertical asymptote at x equals 3, so not consistent with our graph, right? The horizontal asymptote on our graph was y equals 3, not consistent with our graph, which is fine. Again, I just want to kind of say that out loud as we're practicing this. If I look at the formula or the rational function in D, I can see that my denominator zeroes out when x is -1, so I'm going to have a vertical asymptote there. And that factor is not common to numerator and denominator, which is why it's not a whole. And again, this is great that we have a vertical asymptote at x equaling -1, but the graph had one at -1 and 3, so this is missing the one at 3. At least there's no x minus 3 down here in the denominator, so that is inconsistent with our graph. And again, no factor common to the numerator and denominator, so I had no holes here. And if I think about my end behavior, again, I had linear being the highest degree, and the ratio here of lead terms is 3 over that unsaid 1. And that actually is consistent with our graph, right? But the other two aren't. So I'm not going to pick C or D. All right, I'm going to scooch this back up just so we can see some of the graph again. So we've ruled out we've ruled out C and D. Let's start taking a look at other things here. So in both of these graphs, when I look at them, I can see I have an x minus 3 and an x plus 1 in the denominator. So both of the graphs for these two functions in A and B would have VAs at x equaling -1 and x equaling 3. So I can't pinpoint my answer just yet. We're getting there though. Okay, so they're both consistent there. I had no holes on my graph, and I've got no holes in either of these functions because it's not like I have an x minus 4 in the numerator and an x minus 4 in the denominator, right? I don't have a factor common to numerator and denominator, which is fine. All right, so we're gonna decide this with the end behavior. All right, so if I look at end behavior, that's the one time I tend to look at the original formula, right? So x squared over x squared, 3x squared over x squared. They both have the same degree in numerator and denominator. So I'm going to look at that lead coefficient, right? 1 over 1. So I'm going to have a horizontal asymptote of y equals 1 here. But in B, it's 3 over 1. So this time I have a horizontal asymptote of y equals 3. This is not consistent with my graph. This is consistent with my graph. So ultimately, B is my answer. All right. Thanks so much, everyone. Bye.